So I'm going to be looking in this video at solving simultaneous equations. Graphically, what does it mean? What do the equations mean? Just the meaning basically. Alright, we're going to start with two unknowns, and then we're going to move on to three unknowns and three equations. And what does it actually mean? Okay, so first of all, two unknowns, we could have a line that looks like this. This is just the equation y equals x plus 3. We could have another equation that looks like this. This one I didn't put an equation on, but it's negative 2x minus 3. And they cross over at this point here, where x is equal to negative 2, y is equal to 1. So the answer to solving these equations would be x equals negative 2 and y equals 1. You might get an equation that looks like this. And you get two equations. This one's y equals, again, didn't put the equation on it. This one's y equals just x. And you can sort of see they're going in the same direction. We've got the same gradient. They will never touch. So in this case, there are no solutions, or it's inconsistent. The equations are inconsistent. You could, however, move it a little bit. I'll just set the slider up so I can change it. And there'll be one point. Let's get it right on it. That point there. This point here, there's no solutions, no solutions, no solutions. This point here, they're the exact same line, in which case they're infinite solutions, but we say they're dependent solutions. Dependent because it's not all the solutions. There is a value of x, so when x is 1, y is 4, so it depends on what x is. When x is 2, y is 5, again it depends on what x is to find out what y is, or vice versa. That is two variables. You could also have three variables, three unknowns. That means you've got to go to a more complicated graph. You've got to go to a three axes. You'll have a y, an x, and a z. I don't know which one's which on this. I've been rotating it around a little bit. Got myself confused. But anyhow, you might have this sort of situation. Then we can put in some equations. Let's just go for something simple. X plus y plus z equals 1. And you get a plane. So this equation is a plane. It represents not on a line, but all the points on this plane could be figured out. So if you have x, there could be a couple of values you need to sort out for y. Let's have a look. So it's just we call that a plane. So it's just a little flat thing. Some people might call it a plate, but you'll fail on your test if you do. We'll put another line here. So let's chuck in another line. Let's call it x plus y plus z. It's not a z. Z equals 5. There's another plane, and we'll chuck in another one because we said three unknowns, three equations. X plus y plus z equals, let's keep it consistent, 9. Now you can see three planes that never touch. This is like the parallel line example. They are inconsistent. None of these planes are going to touch at any point. I could change one of them. If I just change one of them, that didn't work. So now you've got two planes on, but you can't find any values of x that would suit for both of them. So again, there's still no solutions. So they all have to be parallel. If they are all the same, we won't need to be all the same. Let's just change this one to, let's just get rid of an x. So x is 0. Now you see two planes that are crossing at the same point. Of course, because they're the same same plane, and you get one that crosses them. This one you've got infinite solutions. Oh, that's cool. All the points on that line there are going to be the same at every single point. Those are still infinite solutions. See, if we've seen inconsistent, infinite solutions is called dependent because it depends on what the other values are. I could change this equation here to let's get rid of a y. It's like a 0y. It doesn't really get rid of it. It's still part of the values. And that didn't work. I've got to push enter. In case you're using this program, plus, and that's not the right button. Plus. Right, this time it's going to be hard to see, but there should be one solution that they all meet on. That'll be about there. It's going to be one point that this plane and that plane all meet at one point. That is a unique solution. When you're solving it and you get a value, whatever that coordinate would be the answer to solving that equation. Yeah, so 3 situations, just to recap: infinite solutions, or the NCA term, dependent solutions. They cross over, and there's many answers. Inconsistent, there are no solutions. The 3 planes are parallel, or 2 planes are parallel, and they're never going to meet. And last one, remind me quick. Yeah, that's the unique solution. Would be probably the most common when we are solving them, because there's no point in solving an equation and there's no solution. So, but there are times that it happens. And it's a unique solution. All right, have fun, study hard, and yeah, do that.